Hello there. I will share my screen now. Okay, give me a sec.
Yeah, all good.
Okay, so hi there. My name is Peter Rafaj, and today I would like to present some thought about the building event-driven architecture from my previous experience. So let's jump to it. At the beginning, I would just mention the company I'm working for, the Labyrinth Labs, what we are doing, what we are, and some good chats. We are a one-stop and shop for DevOps, cloud, and Kubernetes. We are helping our customers to build cloud-native applications, migrate to the cloud, and some small, tiny part of our job is also the develop and the design serverless application on top of the AWS. Some info about me. I'm originally from north part of Slovakia, currently located in Serbia. My main stack is Golang and TypeScript. Most of our project I developed in the Labyrinth Labs was mostly in TypeScript. And just one note, we also use SSD, so the information Philip mentioned in the first presentation are relevant. We use SSD. We also use things the Philip developed. It was Purple Stack. You can find it in the GitHub. So it's a nice piece of work. So well done for that. And jump to the event-driven architecture and what we learned during the last half a year. So at the beginning, just a definition what event-driven architecture is. I find a nice quote regarding this. It's architecture style of building loosely coupled software system that work together by emitting and responding to the event. What type of consideration you have to take into account when you think about the building event-driven architecture is define some boundaries. I define some domain boundaries. I think I will talk about it later with DDD approach. Eventual consistency. This is the huge topic in event-driven architecture. Is basically distributed system, and if you build if you ever build even distributed system, you know that eventual consistency is just part of the distributed system. At least once delivery, that's a topic you also have to take into consideration. You have many approaches into this. In ideal world, you would like to achieve exactly once delivery, but that's definitely not possible. There are some well-known patterns which you should take into consideration if you build distributed system. And one little things or big things, I would say it's a mindset switch. You can learn technology, you can learn design pattern, but at the end you should spread the knowledge, you should spread the mindset about the asynchronous communication, event-driven approach, and etc. There are other things you have to take into account, like idempotency. As I mentioned, you can achieve exactly once delivery, so you have to deal with idempotency on some level, or for some of your services, error handling. What kind of approach you take? You can take simple approach where you just, let's say, don't deal the error. Then you can have approach where you would add some more advanced functionality into error handling. Event-driven architecture is really about the events, how to structure events, and how to design the event properly. and at the end monitoring what type of monitoring you should build for achieve reliable event-driven application. So if we jump into it the right way, we have to firstly think about the loosely coupled eventual consistency. What does it mean, loosely coupled? It's approach or design approach in architecture where two services or two systems have little or zero knowledge about internal functionality, and they communicate just through the well-defined API or definition of events, let's say. On the other side, eventual consistency is and the term used in distributed system where any updates to the system is not immediately shown to all the API endpoints, but it will be consistent over the time if there is no other updates into entity at all. I will jump into this a little bit more because it's really important to join it with the mindset switch note I mentioned earlier. This happened for in one of our previous project where we created the application, develop, design, added to the testing stage, and we end up in the situation the developer or testers ask why I don't see immediately see the change which happened in the system, and the reason for that was the fact that we built it distributed way. So at the beginning, when you start thinking about event-driven architecture, you have to think or you have to spread the mindset that okay, system will work, system will operate quite well, but can we tolerate the approach where the system will be not eventually consistent for the whole time, but will be not be consistent over the whole time of the application, but will be switched to the will be eventually consistent. So it was interesting fact that move the mindset of developer and testers to fact that it could happen, but it should not affect the application at all. You should prepare for that, and you should design the API the way that is normal. If we talk about the distributed system or eventual event-driven architecture, typically we talk about the producer and consumer, and something somewhere between are some event bus. I also mentioned broker because this is a general topic for distributed system and all. If you talk about the serverless application, we 90% of the time you will mention or you would select the event bridge, which is the core backbone of the event-driven architecture. So that's the idempotency, loosely coupled eventual consistency. As I mentioned earlier, in the idempotency is fact you have to take into consideration when you build distributed system in general. You can achieve exactly once delivery, and you should for every lambda you using, you should ask yourself what's happened if this lambda accept the event two times, the same event two times in a row. What's happened? Like will somehow affect my application, or it doesn't matter because the functionality work different way. So I would give you the example. We work for financial companies, and where we transfer some money between accounts, and if we wouldn't apply idempotency approach here, what would happen? We eventually could move money from accounts two times. So for that, we definitely use idempotency tool in serverless world, it could be Lambda port tool from AWS. It's already solved problem, so you don't need to take care of it too much. Just import the right package and properly configure it, and you should be fine. Under the hood, it's simple wrapper around your Lambda handler, which write to the Dynamo database to the state of your actual Lambda status, and if there are multiple events with the same content, you can skip those. But on the other hand, we also built application which or we build functionality like an audit log, where we store the actual action in the application into S3 storage, where on top of the S3 bucket there was a glue table and Athena and the query to allow the office management to look at the data from the application. And for the use case, it doesn't make sense to build or inject idempotency functionality into Lambda handlers, because we designed the way that even if you put multiple events with the same content into the Lambda handler, it's happen only that it's nothing happen at all, because we just replace the old file with a new one, but with the same content. So that's fine, or that was fine for our use case. So always take into consideration idempotency for your business logic. You can do it globally in your Lambda handler through the idempotency middleware, or you can do it in your business logic. There are multiple approaches. Then error handling, quite a big topic. Typically, when you have deal with asynchronous workload in the serverless world, you have some SQS queue in front of your handler, which take care of scalability and just pull the data what can be processed by Lambda. And in case there is an issue on Lambda handler where you can process the event after some retry mechanism, basically the event goes to dead letter queue. That's normal approach. Typically, every tutorial on the internet describes dead letter queue as a functionality which you always have to take into consideration or implement into your asynchronous workload. And one approach is simple. We use it in one of our applications. Is you can, through the CloudWatch functionality in the AWS, you can monitor the number of messages in the dead letter queue, and based on that, trigger the alert into your monitoring system. So that's a simple approach. It's work for us, I would say, because it doesn't. Our model wasn't so heavily updated by multiple users. It was always updated by one user in a time, so there wasn't such a collision in the data model. So that's why we use this approach, and it's worked fine. This type of little queue is typically configured on infrastructure level. You really don't care about it. If you hit the limit of retry policy, just the event sourcing configuration do it for you and put the wrong event or message to the directory for you. There is also another approach where you do it manually in your Lambda function, depending on the use case. I would recommend this approach. There is also another more advanced. It's also known as a distributed saga pattern, where if error happen in the system and in distributed system, you should you probably need to somehow change the state of the already created records to even to the error state, or completely remove it from the rest of the application. For that, again, you can you can jump to the dead letter queue messages, and based on the event in the dead letter queue, start some compensation logic through the step function, which eventually trigger new type of event to the event bus, and try to fix the model in the distributed system, or data in the distributed system. So that's one approach. It's just depend on the use case. If I would recommend to use with the simpler approach, and try to adapt, or try to monitor it as much as possible, and based on the use case, adapt if there are multiple errors, and error occur daily. Think about the advanced solution, for example, use the function. That's this slide is more about the mindset switch we talk about. You have multiple approaches. In ideal world, you would like to design event-driven architecture application where everything is synchronous. That's not always possible. There are it's always trade-off, and it's always also situation in the company you're working for, or develop the application for. If your front-end development developers are okay with the synchronous REST API, you probably will not be able to switch their mindset immediately to the asynchronous approach, even use AppSync or some version of WebSocket through the API WebSocket Gateway, or IoT Core. So probably there always will be some synchronous work in your application. It's completely fine, but the rest of application, I would highly recommend to think about it twice, and think about asynchronous approach, where even its integration with third-party services, just this ideal use case for asynchronous processing, building audit trail for many use cases where you need to track the action which happen in the system for a long period of time. You basically don't care when it happen, on where it will be stored in the system, or you just need to know that it will be there eventually. So for that use case, definitely use async approach. Other third-party integration, definitely use case for async approach. On top of that, you have event bus, or generally some broker which share the which you use as a backbone for your application. Now I would like to move to the event, for how I understand the event, what event means to me, or for how we design the events with our application. Typically, event is something or what already happened in the system. We usually categorize events to two categories. It's domain event, which basically describe some action which happen in your system, and then you can have operational event which describe what if maybe some internal operational event which describe what's happened with your system in general. It could be some status about your third-party integration service, like if the system is up or down, whatever. It could be processed eventually, or stored somewhere for future analysis, post-mortem, or etc. How we design or design the schema for our events typically. You can see on the right side of the presentation, the first part of the JSON definition is pretty much you can change it. This is defined by event bridge itself. What kind of data you can change is data in detail attributes. We used to use approach where detail is spread or contain two more attributes. It contains metadata and data. Metadata is purely about sharing the internal information about the event. Typically, you put their record name of the event, correlation ID, some additional information which can help you to filter the events properly, version of the event, etc. And then you have data event or data attributes which share the real domain values of your application. So I would say the event-driven architecture is fun, but on the other hand, it's also really hard. I learned it the hard way because generally event-driven approach is lead you to the building distributed system. Distributed system in general are really a problem. And if you don't pick up the right approach there, you can end up in the anti-pattern, which you can find on the internet as a big mud of mud. So that's it. What other things you can use to design better event-driven application? Is domain-driven design. Again, some quotes. If you're not familiar with this concept, is the software design approach. Focus on modeling complex business domain using rich, expensive domain model, then reflect real-world rules and workloads. It's quite a huge topic. There is even a conference about DDD, and it's challenging to catch all the detail. But at the end, if you jump into it, you can benefit from it in the building event-driven architectures, especially if you look at the three main things. I would highly recommend to focus. It's a bounded context, aggregates, and ambitious language. What it's all about? Bounded context is typically when you have some domain which has to be solved by software. So you as a technical person, you sit with the domain expert and try to find some solution for the domain problem. After a couple of discussion, you should find or define some initial language which exactly define what define name for the internal system component or domain component, and you should stick with that and use it in your architecture diagrams, definition of diagrams, and etc. And you should stick with it, and it help you to better understand or it helps to better understand the software we are building, because also the domain expert and also the technical person speak the same language. Then we have a bounded context, which is which could help you to properly design the service the way that they operate within the own context, and they share just the information they should share. They don't share the internal events which are not meant to be shared. The last things I would highly recommend to look at it is aggregates or root aggregates, which describe the fact that you model your domain as a root, where you have root aggregate and gallery of the objects somehow connected with the root aggregate. And if you change the state of the application, you change the aggregate and all the objects related to the aggregate in the transaction, and it means that you switch the aggregate from consistent state to another consistent state in transaction, and the output of this transaction should be aggregate is updated properly with all the dependencies to the other objects, plus you also generate domain event, and that's nice things, nice things you should learn, or you should take a look at it. That the producing events can be distributed to the other part of the application, and on top of that you build the other representation of the data. I would highly recommend these two type of books. The bottom one is quite hard to read, but definitely you should try it. It's more than 20 years old, but still valid. The top one is a little bit younger and still quite good, I would say. And now I would like to jump to the pattern I use in previous project, and I would recommend for the building event-driven architecture. That's first one I would recommend is transaction output pattern. As I mentioned earlier, typically when you have aggregate, you wanna in one transaction you would like to store the all root aggregate with all its dependencies to the other entities in the one transaction, and also the emit events. For that, you can easily build this requirement on top of the DynamoDB, a DynamoDB stream, with the help of event bridge pipe and event bridge itself. How it works? Basically, you stored, this is the example of DynamoDB table. You first record represent the aggregate or record you want to store. Typically you have some PK sort key, doesn't matter. We, from our experience, we store also some type which describe the data which are stored in the Dynamo. And next to it, in the one transaction, you also save event. Typically, event has some event ID, some timestamp, its type event, and in data, it's contained the full domain object, which should be shared across the boundaries, across the event bridge to other subsystem. And this is written to the DynamoDB table, and from the Dynamo stream, it's distributed to the event bridge. When to use it? Definitely when in one action you want to store your data and notify others. It came to the fact that if you use this approach, you reduce dependencies with Lambda handler. I'm okay with that if you store data to DynamoDB and then through the event bridge client put the event to the event bridge. It's fine. It will probably work, but we use this approach to be less or build the Lambda the way that it's work less or doing the less work. So and you definitely you share the data safe way. in that case use this approach. When you shouldn't use it, if you really hunt every cent in the AWS bill, it's something. It's somehow connected with the fact that DynamoDB charge you twice as much as a normal write operation if you use transaction in Dynamo. And didn't have a good experience with this approach. If you build real-time application, it means that for one of our client we built the system which integrated with the third-party services, but it has to be integrated in real time. There should be minimal delay, and we use this approach, and at the end we have to rewrite to the old school style where one Lambda do almost all the work in one shot. So don't use it if you need real time or really real time approach. Yeah, that's one pattern. The second one we use quite frequently is store REST API, and then later, if you process data correctly, you can through the callback return the real response related to the business needs. You can use this pattern. The flow is basically that you have an API gateway Lambda. You did some validation on a Lambda and eventually save the request with some metadata into Dynamo, and then it's processed from DynamoDB stream to the rest of the application or to the business logic. When you should use it, if it's okay to for you to return 200 and process later, as I mentioned earlier. What is a nice way, or what is a nice feature of this pattern is that you can easily rerun the request which wasn't processed correctly or there contained some business error. You can easily look at it. It's written in the or it's stored in Dynamo for some period of time, and you can eventually create the new record in Dynamo, which will contain the fix for the record, and you can rerun it automatically if you want. And it's okay if you can respond to the original request for the webhook. So use it. And how it looks like in the Dynamo, if we take to example with Dynamo DB stream again, some event ID timestamp as a primary key and sort key, and we used to take the whole request from the HTTP gateway and create some internal representation of the request as an event, and store it into Dynamo, and then process later if we have a time for that. So that's the second pattern I would recommend. And the last one is circle breaker pattern. Typically, when we use it, when we want to block the call to failing service, typically when you work in with multiple services, you integrate the service you can't affect. It can break, it can return or respond slowly. It could be into maintenance state, so it returns 500 or something like that. So you wanna be aware of it. So you can't or you want to fail fast, because if you will wait for 10 seconds for the response, you will pay for the 10 seconds. So you would like to fail fast and be aware of it. And you want to prevent the cascading failure if your workflow are dependent on the other third-party services. So you want to fail quickly. And how we implement that, we basically we have some scheduler, which, by the way, the circle breaker have multiple version. This is some semi-complicated, or there are multiple other versions, and this version is based on premises that you can rerun the request which should be sent to the third-party services somewhere in the future. So we periodically check the health check of the service, let's say every minute, every 2 minutes, to check if the service is up and running. Based on status from this HTTP request, we update the status in Dynamo. Eventually, this could be distributed to the other part of the application if there is a use case for that. And if Lambda, which is responsible for sending requests to the third-party service, get the event, firstly we, through the middleware, check the status of the third-party service, and if the status say that third-party service is down, we immediately return the event to Event Bridge archive, and not process the request at all. And if sometimes if it happened that the request is, or the status of the third-party services is changed from down to up, this triggered our reply handler, which communicate through the Event Bridge API and trigger reply archive from Event Bridge. This lead to situation that all the events which end up in the specific archive will be replied back to the system, to the Event Bridge, and Lambda could reprocess it back when the third-party services is up and running. This is some limitation. It's again up to use case, how to use it or when to use it. It's could took I think the 5 minutes until the data from the archive are propagated to the Event Bridge. So if you want to use it, you can definitely. It's a good approach, but take into consideration this limitation. And when you should use it, when you want to fail fast, you can use, in case you can use retry and reply strategy, and you can tolerate postpone synchronization. As I mentioned earlier, there are plenty of other versions of circle breaker. There is also a version where there is a semi-open circle breaker, which pass some percentage of requests to the third-party service. Then the breaker could be open or closed, and that's another version. Or if you want to really fail fast and you didn't care about the some reply, you can just return immediate error if the service is down. So that's I think all from my side. I would just briefly mention some takeaway. I would highly recommend to look at it. Definitely take into domain-driven design and think about asynchronous mindset switch. I believe that for many of you it's just the normal thing to spin up the AppSync or WebSocket, but for still there are plenty of other projects or other teams which can take such advantages. So just think about it. And that's all from my side. Thank you.